All right. Just in case you were interested, I am going to go through how to do regression models on a graphing calculator with you if you'd like to do this. So here's the idea. We can take some real-world data, and if it's following some sort of pattern, we have mathematical abilities to kind of fit a function to it. And while it might not be perfect, these functions can help us predict things in the future, in the past, whatever. So we can use these functions to answer future questions. Our calculators have a lot of ability to do regressions. So in your stat button, so underneath the delete key, this is where your statistics stuff is. If you go over to the calculate menu, you can see a bunch of types of regression. We have our linear regression, where the number they give you is the slope is A and y-intercept is B. Quadratic regression, cubic. So basically what these are is if you have data points and they look like they're following kind of a linear pattern, you would try to do a linear regression with them. If they kind of had like a parabolic shape, you'd try to do a quadratic regression on them. For the ones that we have, you have lnreg, which is our logarithmic regression. We have our expreg, which is our exponential regression. So if we have data that follows an exponential pattern or a logarithmic pattern, you can use those. And then we have this other one, logistic, which is that thing that we did at the end of class on Tuesday. So how we do this is we take, oops, you can see the answer down there, I'll cover that up. You take tables and we fit functions to them. So here's a table. It says write exponential regression equation below. How you do this with a calculator. So first of all, we're going to enter this data as lists. To do that, you hit stat. In the edit menu, you're just going to hit edit. So you're going to hit enter. And if you have something in these lists already, if you scroll up to the top and hit the clear key and then go down, that'll get rid of a list. So like let's say you had something in there and you don't remember why it's there, but it's there. If you go up to the top. So you can delete each of these individually. So you can go to this and then hit the delete key and it's gone. Or you can go up to the very top of the list, hit clear, and that'll delete all of them. So each of these columns we're going to put in its own list. So 2.5, 3.5, 4.5, 5.25. Let's say you made a mistake. You can go up, you can delete each of these one at a time. Remember, you can just hit delete. It'll get rid of it. Then you have to type in everything underneath it again. Move over to list 2. We're going to type in 0.175, 0.38, 0.63, and 1.2. Once you have these two lists, take a look at what list names you put them under. Mine is list 1 and list 2. You could have used any of the other lists. Sometimes people accidentally delete lists. So you're like missing a list 2 for some reason. I can show you, but that'd be more of a me and you working together thing, how to put those back if they are missing. But how do we find the, what did it want? Exponential regression. You're going to hit stat again. You're going to go over to calculate. You're going to find exponential regression. You're going to hit enter. X list is list 1. That was my first list. I put it in list 1. If you put it in list 3, how do you make another list show up? They're the second options on these numbers. So if you did it in list 3, you'd hit second 3 to make your X list L3. But mine are in L1 and L2. Frequency list, don't worry about. Store reg EQ. This is nice if you want to graph things. Maybe I'll talk about that later. Otherwise, you just hit calculate. Y equals A times B to the X. A is about 0.033 maybe. B is 1.968 or 1.97. R squared and R are values that kind of give you an idea of how well the function fits the data. The closer R squared is to 1, the better. So this is really close to 1. So this function hits these data points really, really well. It's really, really close to fitting all of them perfectly. So there is my function. Y equals 0.3 times 1.97x. Check the data, or graph the data. Okay, so never mind, I actually have to graph this. So here's what we're going to do. Go back to stat, you're going to do the exact same thing. Go back to exponential regression. You want to graph this function without having to type in this stuff. Here's what you're going to do. On store reg EQ, under our vars button, we're going to bring up y1. So you're going to hit vars. You're going to go to yvars for y variables. You're going to go to function, and you're going to click on y1. What that does is it's going to take the output of this regression and put it into y1 in our y equals menu. I'm going to hit calculate. It's going to give me these big long numbers. And instead of me having to type all of this, I go to my y equals and boom, it's already there for me. Now, you want to see this graph, you want to see the data points at the same time, you have to turn your stat plot on. How do we do that? You scroll up so that it's highlighting plot 1. You're going to hit enter. That's going to turn your stat plot on. Now, we can go to our graph, but I want to make sure that it's hitting all the right numbers. So look at our x values. 2.5 to 5.25. I'm going to make my window for x go from 0 to 10. Scale is fine as 1. For y, look at our y numbers. 0.175 to 1.2. So for my y's, I'm only going to go from 0 to, like, I'll say 2. Let's make my scale 0.5. Why not? It doesn't matter too much. You hit graph. It graphs the data points, and it graphs the function through them. We can see that our function hits our data points really well. It almost goes through all of them perfectly. So an exponential regression is really good for this table. Other things wouldn't fit as nicely. I know it doesn't say it in this, but what if I did a linear regression? Because I thought those data points look kind of like a line. I'm going to store my function in y2 so that it'll graph both of them. I'm going to calculate. I'm going to go to graph. So there's the exponential regression, the function fit to those data points. And then here's the linear regression. Just kidding. Where is it? There it is. There's my linear regression. Doesn't hit it as well. Kind of goes between the points. Doesn't hit any of them perfectly, but it's in the middle. There's 2 on the left part, 2 on the right part. So the exponential function fits really well. That's a pretty good regression. Now, it asks us to then find the population at 6.5 hours. Here's a couple ways you can do this. So first of all, I'm going to go back to my y equals. I'm going to get rid of my linear one. We don't need it. What can we do to find it? So the first thing you can do is go to your table, but in your table you won't have 6.5 hours. You're going to have 0, 1, 2, 3, and you're not going to guess in the middle of these. It's also going to be a pain if you have to type in all those numbers and then type in 6.5 into the x in the exponent. So here's a couple things you can do. If you hit second window, that's going to bring your table setup. What you can do for tables is if you go down to independent and you go to ask, that's going to allow you to choose what is on the x row of your table. So if you highlight and click enter on ask and you go back to your table, second graph, you will notice that it's empty. But it allows us to type in whatever number we want. So I type in 6.5, there it is. 2.6826. Already did that. Another way you can do this. If you have this function stored in y1, these calculators can actually do kind of like a function notation. So how we would do that is on your main screen, you would hit vars, you would go over to our y1 function, and you would click it so that it enters. If you put parentheses 6.5, this is telling the calculator, take 6.5, plug it into the function that you have saved in y1. That will also give you a way to evaluate a function without having to type those big long decimals. Okay. When will the population reach 2.1 grams? Here's what I would do for that one. I'm going to go back to my window. I'm actually going to make my y max 2.5 now because we want 2.1. And I'm going to look at my graph. If I want to know, I mean, you can see me, I did a little bit of solving here, which is fine. If you wanted to do it graphically, here's what I would do. I would set what I wanted equal to 2.1 as another line. And then I would just trace where they intersect. So I would go second trace, intersect, first curve on the blue, that's good. Second curve on the red, get kind of close to their intersection point, hit enter. 6.138 is about what I'm getting. If you do it by hand rounded, you get about 6.27. They're different because the calculator is going to have that whole function where I rounded with my handwork. But you can also do this on the calculator, graphing how much you want your y to be and looking where they intersect. You could also go to your dependent and you can turn that on to ask as well. You can type in 2.1. I'm doing something wrong, but do I have to do them both on ask? Okay, never mind. I thought I knew how to do this. Apparently I don't. Sorry about that. Don't worry about it. Okay, I'm going to do one more. I'm actually not going to do the last problem. I mean, you can figure that one out yourself from what I'm about to do, but let's take this nice long table. It wants us to do a logistic regression. So, I mean, you can see the answer already, but whatever. I'm going to go back to my lists. I got new lists, so I guess one more time. Stat, edit, click enter. I don't want these lists, so I'm going to scroll up to the top. I'm going to hit clear, scroll down, and gets rid of the whole thing. Go up to the top, hit clear, scroll down, gone. So instead of typing in 1993, we're going to use 1993 as 1. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Over here in the other list, 5.53, 5.61, 5.69, 5.77, 5.85, 5.93, 6.0, 6.08. So double check your list. Make sure you didn't type them in too fast. You type it in wrong, you'll get a different answer than me. Logistic regression. So we go to stats, we go to calculate. Scroll down, and you can scroll up, it'll be faster. Find logistic, hit enter. I typed my X list in L1, I typed my Y list in L2. You want to see the graph, we can go to store reg EQ, vars, yvars, function y1, calculate. This one takes a little bit longer, a little bit more to do for this one. So, C over 1 plus A times e to the power negative bx tells us our A is 0.628, which I rounded to 0.63. Our B is 0.039, which I rounded to 0.04. Carrying capacity, I rounded to 8.87. Put that all right there. Predict the population in the year 2023, which if you follow this pattern would be number 31. So you can go to your table. I'm going to turn my dependent back onto auto because I was doing something wrong there. Type in 31, and you see that what pops out is 7.4778. The other thing you could have done is you could have gone to vars, yvars, y1, and done the function notation of plugging in 31. Gives you the same answer, just a couple more decimals if you want it. 7.48. So, I probably went through that a little fast if you've never done this before, but that is how we can input lists, how we can do regressions, how we can fit data onto... Sorry about that. I was going to show you the data. I got to change my window, though. I forgot about that. 0 to 10, that's fine, but our scale needs to be 0 to 10. That's going to be better. How we can see our data and fit functions through them. Okay. Bye-bye.